Right. So the first thing we have to kind of go through is that there are more than one ways to measure angles. There are actually about 4 different ways to measure angles. I know from primary school days, you would measure angles in degrees, like all the angles, like if you have a triangle, one angle could be 60 degrees. You're more accustomed using what? Degrees. But another popular way of measuring angles is radians. Just like I would have more than one ways to measure length. Some people use centimeters, some people use kilometers, some people use inches. In maths, there's always more than one way of measuring the same thing, right? There's always more than one way, right? So, right? Let's just do a quick thing here. I don't want to spend too much time on radians. Or this is what I want you to know. There are 2 formulas. Like for example, if somebody were to give you degrees, there must be a way to convert it to radians. Just like if somebody gives you something in centimeters, I'm sure there's a formula out there that can convert what? Inches into centimeters or centimeters back into inches. So the same thing with angles. Like for example, let's say somebody gives you 60 degrees and you don't want to use degrees. Let's say you want to use radians. Well, this first formula on top allows you to convert degrees into radians. To convert degrees into radians, all you have to do is say pi on 180 and multiply by how much degrees you have. In this case, it's 60 degrees. Now, but we're just going to pretend you don't have a calculator on you. So if you simplify this, right, and this will cancel out, right? And you'll get what? Pi on 3, because 6 into 18 is what? 3. And look, I have it on the table here. 60 degrees is the same exact thing as pi on 3 radians. Examiners have the habit of expressing, like when they express something in radians, they normally like it in terms of pi. So there are a few values you have to memorize by heart for the exam, right? And you're going to be taking on the table in a little while, right? 0 degrees is the same thing as 0 radians. 30 degrees, if you use the formula, is the same thing as pi on 6 radians. 45 degrees is the same thing as pi on 4 radians. And you all kind of get the gist over here, right? You have to be able to switch back and forth from degrees and radians and vice versa. Because believe it or not, even though we grow up with degrees, scientists, a lot of scientists and mathematicians don't actually use degrees. For some strange reason, they prefer radians. So let's do me a favor, right? Just take down everything on the screen, including the chart, and we'll move on to, how do you say, more interesting things, right? More interesting things. So let's move into the core of what I want to teach today. And I want to show you how different maths trigonometry is to regular boring maths trigonometry. I know some of you are watching this crazy little table here, and you're wondering, what is that? Hear me out first. Pretend we're in regular boring maths class. If I come and say cos theta, remember theta is the angle, and I want everyone, we're working with regular boring degrees for the time being, so make sure your calculator set the degrees. You think you all could solve for theta for me? This is the one, if you're trying to solve for theta, you want theta on one side and everyone else on the other side, right? So you would draw across cos to get cos inverse. You think everyone could solve this for me? Just quickly and send the answer on the chat. Remember, you're throwing across cosine, you'll get what? Cos inverse, because when you throw across something in maths, you just get the opposite. Tell me what you get. Right? It's really important you send your answers on the chat, and guys, just don't sit down there and, don't send anything. Right? Always go to 2 decimal places. That's right. You have to go to 2 decimal places. This is not a trick question. I'm not trying to trick you guys in any way. And on my calculator, I am seeing 48.70 degrees. And most people should see that if your calculator is on degrees mode. If it's not on degrees mode, Google how to change it to degrees mode, because everybody's going to have a different calculator, a different model, a different brand, right? Great. So people are getting the answer. Now, that was a real simple question, right? No tricks in it. But here's the difference between additional mathematics and regular boring maths. In regular boring maths, if they ask you to solve this, you just only get how much answers? One answer. And that one answer for this particular question is 48.70 degrees. In AdMaths now, unfortunately, gets a little bit more complicated. Whenever they ask you to solve a trigonometry question with sine, tan, and cosine, you just at least get 2 answers. So you're probably wondering how to get the 2 answers. Well, it have a little chart here, right? Let me just erase everything. If you notice here, let me just draw this back. You notice it have a little cross. I think you all can see the cross here, right? It's in yellow. The cross has 4 sections. Section 1, you just read it backwards. Section 1 is here. Section 2, and then you go here. Section 3 and section 4. You will notice that in section 1, the formula over here is alpha. The formula in section 2 is 180 minus alpha. Obviously, you don't know what these things mean as yet. In section 3, the formula is 180 plus alpha. And in section 4, you see in a formula 360 minus alpha. And you will also see little notes on top here. In section 1, it is written that everything is positive. All is positive. What does that mean? All positive means sine is positive, cosine is positive, and tan is positive. Because trigonometry is basically 3 things: sine, tan, and cosine. When you go into section 2, you see a different note. You see sine is positive. This means in section 2, only sine is positive, not everybody. Only sine is positive. And everyone else who is not sine is negative. So in section 2, sine is positive and the other 2 guys are negative. In section 3, it states that tan is positive. So tan is positive. So if tan is positive, by default, everyone else is what? Negative. Now, I obviously I didn't write in section 3 or in section 2. If I say tan is positive, it's understood that the other 2 are negative. And in section 4, cosine is positive, which means only cosine is positive in section 4, but everyone else is negative. Now, obviously, you're scratching your heads and you're wondering, what's the significance of, like, for example, in section 2, sine being positive and everyone being negative? I will show you how to use it, okay? This here is one of the hardest things to explain in trigonometry. So I will be spending quite a lot of time on this. It's usually a very slow burn, but I'll take my word for it. By the end of class, everybody will get it. So first things first, I want everyone to take down this table for me and take down this note, right? The note says, at the point of throwing across sine, tan, or cosine, if the number is negative, temporarily ignore the negative sign. Just take it down. You don't have to understand what it means as in. Let me know when you're taking down everything to the right-hand side of the screen. And then we're going to redo this question here. So when you're doing a trigonometry question, the first thing you have to ask yourself, it's what kind of question is it? Is it a positive question or is it a negative type of question? Because apparently this chart is saying something about sine being positive or cosine being positive. And if cosine is positive, the rest of them are negative. But here's the thing. You can only determine whether the particular question is a positive type of question or a negative type of question at the point of throwing across the sine, tan, or cosine. So make a different color. So in this question, to solve for theta, there's only one thing we really had to do. We had to throw across cosine. So when we throw in across the cosine, look at the number on this side of the equal sign. So at the point of throwing across the cosine, ask yourself, look at the number on this side of the equal sign. Is that particular number positive or negative? Well, isn't 0.66 a positive value? So this is a positive type of question. It's not a negative type of question. I'm going to repeat it. The reason it is a positive type of question is because when we are throwing across the cosine, well, the only thing to throw across in this question, the number waiting on the other side is positive. Now, here's the thing. It's not just a positive type of question. What's the trig function today? Cosine. So it's a positive cosine question. So that's the type of question it is today. So here's what. Remember when we had thrown across cosine, we had gotten cos inverse 0.66. And when we did that, right, we got 48.70. You see the very, very, very first answer we get? You just call him alpha. Another word for alpha is the basic angle. So usually the first answer we get is your basic answer. Now, in today's question, this answer is our first answer, but usually you just get two answers. So here's what we have to ask ourselves. Where in this diagram is cosine positive? Because it's a positive cosine question. Do we all agree? But by the way, I call it section 1, section 2, section 3, and section 4. But the real names is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Where is cosine positive? Isn't everybody positive in quadrant 1, including cosine? And where else is cosine positive? Cosine will be positive in two places. Do we all agree that cosine will be positive in quadrant 4? It clearly says that. Because everybody is positive in quadrant 1, and cosine is positive in quadrant 4. So to get our second answer, we have to use the answer in quadrant 4. To get our second answer, the first answer, just call it theta 1. And the next answer, theta 2. What's the formula in quadrant 4? 360 minus the basic angle. Look at it, 360 minus alpha. Alpha is the first answer we get, which is 48.70. So what's our second answer? 360 minus 48.70, which is 311.3 degrees. You see, the formula in quadrant 1 is just alpha. Alpha is just the first answer you get. Don't worry, this takes a little bit of practice, guys. I know most people here, you only got about 50% of that. You only got 50% of that. Give me some time to work with it. And you'll understand 100. Huh? right? Another word for the basic angle is the principal angle. So some people call it the basic angle, some people call it the principal angle. Let's just call it alpha to keep it short, right? Or we could just call it the first answer. Keep it simple and we'll get technical terms down afterwards. Right. Let's change up the question before we move on to something harder, right? Right. I want to change up the question, right? I'm not changing the slide. Let me just give me a few seconds. Let's change this question to let's remove cosine, right? And let's remove the 0.66. And let's change this to, let's see, tan theta is 0.78. Everyone write down that question. Let's try this question. Let's say you open your CSEC past paper or on the day of the exam, and you see tan theta is equal to 0.78. It's clearly a tan question. Clearly, it have the word tan in it. Now, you can't determine whether it's a positive type of question or a negative type of question as yet. You can only determine that when it's time to draw across the tan. So you only have one thing to do in this question. It's a simple question. To solve for theta, we have to draw across tan. When we are throwing across tan, what is waiting on the other side? Isn't it positive 0.78? So this question is a positive tan question. When you throw across tan, you get tan inverse 0.78. Remember, the first answer you get in a positive question will be alpha, your basic angle, or if you want to call it your principal angle. How much is tan inverse 0.78? Tan inverse, second function, tan 0.78. I hope you all see the same thing here. I get 37.95 degrees. I'm hoping you all see that. Right. So remember, the first answer you get, right? The first answer that you get is alpha, right? His name is alpha. Now you have to ask yourself now, since this is a positive tan question, where is tan positive? Tan is positive in the first region because everybody in quadrant 1, because quadrant 1 says everybody is positive, including tan. And also, where's tan positive? Isn't tan positive in the third quadrant? So tan is positive in two places, quadrant 1 and quadrant 3. The first quadrant, the formula in the first quadrant is just alpha. We already found alpha. To get the second answer, we have to use the formula in quadrant 3 because tan is also positive in quadrant 3. So in other words, whichever quadrant it falls on, you use the formula, obviously, in that particular quadrant. So quadrant 3 formula is 180 plus alpha. How much is alpha? 37.95. 180 plus 37.95 is 217.95 degrees. That's your second answer. So the two answers is 37.95. That's the quadrant 1 answer. And the second answer is 217.95, which is the quadrant 3 answer. Yeah, life just got a little bit more complicated. Right? You want to hear something even worse? I know we getting what? 2 answers, right? But in reality, you know how much answers it is really have? Infinite. Don't worry. Even though there's an infinite amount of answers, the most amount of answers you're going to get for CXC is probably 4. Right? We're going to have to find 4 answers. In rare cases, 6 answers. But let's keep it simple. We're sticking with 2 today. Now, these questions, I consider them easy, the easy part. You know why it's easy? Because it's a positive type of question. Look at it. The question we did before was a positive type of question. It was cos positive. And the question we just did was tan positive. Whenever you're throwing across the sine, tan, or cosine, and it's a positive value weighted, the question, that's the easiest possible question you can hope for in the CSEC exam. Obviously, sometimes when you're throwing across the tan, sine, or cosine, a negative value will be waiting for you. Whenever it's a negative value waiting, that is where this note comes in. And of course, I have to show you how to use that note. Let's move on to the next slide, right? Let's move on. Haha, a negative question. Who would have thought, right? So everyone write down that question. Tan theta is equal to negative 0.75. Actually, it's too early to determine whether it's a positive or a negative question. We can only determine whether it's a positive or negative question at the point of throwing across the tan. Only then we can decide whether it's a positive question or a negative question. Anyway, take down the question and let's get started. All right, let's go. So let's throw across the tan. So we want to solve for theta, right? So we take tan and we throw it across. But when the tan going across, he's like, whoa, 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 hold up. This is not an easy question. A negative value is waiting for him. So he's like, oh God, I hate when a negative value is waiting on the other side. Because this is going to end up being what? A tan negative question. And nobody likes negative questions. So how do you deal with a question when a negative is waiting? Look at this note here. Whenever you're throwing across the tan and you see a negative, ignore the negative sign. I know it sounds like bad advice, but that is what the note is saying. So here's what you're going to do, right? Tan inverse and ignore the negative sign. I know you're seeing negative 0.75, but you just find the tan inverse of positive 0.75. Just do that for me. Just do that for me. Find tan inverse of positive 0.75. Ignore the negative sign. It's like when you don't like somebody, you just walk straight past them like they're not there, right? Same thing with the negative. No, guys, you're ignoring the negative sign, right? You're typing in tan inverse normal 0.75, not negative 0.75. Ignore the negative sign, right? Second function, tan 0.75, I am getting this. I am getting positive 36.87. How much of you are seeing that? I'm checking through the chat here. Guys, you gotta listen to the instructions. Ignore the negative side. Right. Now, here's the thing. This first answer you get here, he's alpha as usual when you ignore the negative sign. But he's not one of the final answers. He's just alpha. What you're going to do now is use alpha to get the two answers. So in other words, when it's a negative question, when you ignore the negative sign and you solve, alpha is not one of the answers this time. He's not one of the answers. So now, how do we get the two answers? Ask yourself, where is tan negative? See if you all can figure out in which two quadrants is tan negative. Think it through. Think it through. We'll see what you'll come up with here in the chat. Right. But I don't want to call all the answers on a reason at all. Remember, everybody is positive in section 1, and tan is positive in section 2. So that means tan will be negative in section 2, and tan will be negative in section 1. Because remember, section 2 says only sine is positive, which means everybody else, including tan, is negative. And section 4 says cosine, only cosine here is positive, which means sine and tan are negative. So we have to use the formulas for section 2 and section 4. You think you can get the 2 answers for me? Call the 2 answers theta 1. The quadrant 2 formula is 180 minus alpha. And quadrant 4 is 360 minus alpha. And we know how much alpha is. Alpha is 36.87. Replace this alpha with 36.87 and also replace that alpha with 36.87. And that will be your final 2 answers. Right? In other words, if you know where it is positive, like if you figure out which section it is positive, then it will be negative in the 2 other sections automatically, right? So that's another way of saying it, right? If you want to figure out where something is negative, just ask where it is positive and then choose who's not that, right? I guess I should have saved like that first, right? So 36.87 here and 36.87 here. Theta 1 and theta 2. I hope you get these 2 answers. 180 minus 36.87, 143.13, 360 minus 36.87, and this one here is 323.13 degrees. You're probably wondering why life has to be so complicated. What happened to the good old days when trigonometry just gave you 1 answer, right? Right? If you're getting this without my help, you're on real good grounds, meaning that you ain't gonna have a hard time today. You can put any answer first, by the way. If you put the 32313 first and the 143 after, it's still correct. Just get the 2 answers in any order. Okay. Right, so half a minute, and we're gonna change the slide. So I just asking, how much percent you think you understand so far with the positive and negative types of question? Out of 100%, what percent you think you're up by? All right, a little brain relaxer before we move on to something else. So here's how the game works, right? You're going to be given 2 choices, right? You're going to be given 2 choices. You're going to vote. And if you are part of the more popular choice, you get 10 points. So keep track of your points. If you're not part of the more popular choice, you just get 0. Right? So let's see the scenario here. Right? It's getting music playing. I love the music at this one. Who do you think will win if they fight? Right? All right. So you all want to try this question for me? Sine theta is equal to 1/3. Now, don't let the fraction get to you. I'm hoping you all could use the fractions button on your calculator, right? If for some reason you can't use the fractions button, like if you have 1/3, you could just put it as a decimal to 0.33. But I would prefer if you use the whole fraction. Well, what you could do, right? If you don't know how to type in fractions, like when you draw a cross sign, right? and you'll get the sine inverse, but it's the sine inverse of 1/3. How do you write 1/3 without using your fractions button? It's real easy. Just press open brackets. You have to use the brackets. 1 divided by 3, close brackets. But you have to use the brackets. That's the same thing as 1/3. You think you all could do this question for me and send me 2 answers? You determine whether it's a positive question or a negative question, and which 2 quadrants you have to utilize and whatnot. Good luck, and I await your answers for this one. Now, this is obviously a positive type of question because it only have one thing to throw across to solve the equation. And at the point of throwing across that one thing, the sign, what was waiting on the other side? Positive 1/3. So this is a sign positive question. So let me just work out this here. Sine inverse this is 19.47. I use the whole fraction. If you use 0.33, like you round it off to 2 decimal places, you'll get a slightly different thing than 19.47. Just slightly. Now, when it's a positive question, right? Remember, the first answer you get is always alpha. In a positive question, remember, sine is positive here in this, and sine is positive in the second region. Look at it. Everybody is positive in quadrant 1, and sine is positive in quadrant 2. The formula for quadrant 1 is alpha. So my first answer is alpha. My second answer would be 180 minus alpha, because that's the formula in section 2 or quadrant 2. Right? So I'll work it out here and I'll put the answer here. 180 minus 19.47, and I'm getting 160.53 degrees. Make sure I put your degree sign. Right? So this was a quadrant 1 and a quadrant 2 question. Try this one. Remember, 2/5, negative 2/5. If you don't like 2/5, replace it with 0.4, because 2/5 is the same thing as 0.4. The main thing about this one is I don't want fractions to intimidate you all. But anyway, you all figure out whether this is a positive question or a negative question and see if you can provide 2 answers. All right. So, if you're not a fan of the fractions, that is no problem. You just say cos theta is equal to minus 0.4. So we start off this, it's only one thing to throw across, the cosine. That's the only move in this question. But when you're throwing across it, it have a negative weighting. So this seems to be what? A negative type of question. So it's a cosine question, and it's a negative cosine question. All right, when it's a minus question or a negative question, we know it's a little bit harder. That's the note over here, right? It says at the point of, whenever it's a negative question, at the point of throwing across a sine, tan, or cosine, if it's negative, ignore the negative sign. All right, that's what the note says. That is why I do it. So I find in the cos inverse of normal 0.4, not negative 0.4. Let's see how much we get. Cos inverse 0.4, I'm getting 66.42 degrees. Now, this first answer is your basic angle or alpha. When it's a negative question, this first answer is not one of your official final answers. You just end up using it to find the 2 answers. So now you have to ask yourself, where is cosine negative? Because this is really a negative question, right? You can't ignore the negative forever. So the best way to do it is, well, we know cosine is positive in region 1 and region 4, right? So that means if cosine is positive in 1 and 4, well, then by default, it will be negative in the other 2 regions. region 2, and region 3. So the two formulas in region 2 and region 3 is 180 minus alpha, so 180 minus 66.42. And the other one in region 3 is 180 plus 66.42. Theta 1 and theta 2, let's add it and subtract it. 180 minus 66.42, I'm getting 113.58 degrees. And 180 plus 66.42, 246.42, right? I use this formula and I use this formula. If you got it wrong, just check back your answers, no? Right? Right. Now, I know there are slightly different ways of doing this question, right? It have one other different way to do the question. I don't want to show everyone both ways, right? I already don't because I'll just confuse you, right? So I'm sticking with this method, right? All right, take down this question. This question is harder than it looks. You take it down and wait on me. Do not attempt this question. Minus 2 sine theta is equal to 0.65. All right, let's get started. Now, remember, when you have these types of questions, you have to make a decision. Is it a positive type of question? Or is it a negative type of question? Now, we know it's a sign question. That is not a mystery. It is a sign question, no doubt. Okay? No doubt. But some people might rush and say, hey, the value on this side is a positive value. So it has to be a positive sign question. It's too early to make that call because we can only determine whether it's a positive or negative question at the point of throwing across the sign. But this question is minus 2. And in maths, when you have two things touching like a number and a letter and nothing in between, we know by now it's a secret multiply. So this is really minus 2 multiplied by sine theta. And the aim of the question is to solve for theta. Who is the first person we throw across to solve for theta? Not the sign. We have to throw across Mr. Minus 2. And by now we know when you throw across a multiply, you just get what? A divide. So you get 0.65 divided by minus 2. Remember, when you throw across a multiply, it becomes a divide, but the sign does not change. Basic algebra. We haven't thrown across the sign as yet. We threw across the minus 2. So sine theta, let's divide 0.65 by minus 2. 0.65 divided by minus 2. I keep it all 3 decimal places, right? Because it's such a nice decimal. I'm not going to round off. Everyone take down up to there. Remember, we're trying to solve for theta. But the first person to throw across is not sine. You have to throw across the minus 2, which is a multiply. Right. Now it's time to throw across the sign. Now it's time. So when we throw in across the sign now we could determine whether it's a positive or negative question. You see, when you're throwing across the sign, what is waiting here? A negative. This is really a negative sign question. You think you all could take the question from here now? I think you all could do it from there because from this point, it's a regular boring question that we did before. The only point of this particular question is that you can't make a judgment call too early in the game. You can't say it's positive or negative as yet. Only when it's time to throw across the sign tan, or cosine, then you could determine it. Right? So finish off the question. So we're ignoring that minus sign, right? So theta is sine inverse positive 0.325. Let me see. Second function sine. We're getting roughly 18.97. But this first answer, well, here's alpha, right? Remember we said when it's a negative question, the alpha is not actually one of the answers. We're just going to use him, right? 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 We're just going to use him to get our two answers. So at the end of the day, this is a negative sign question. Where is sign negative? Well, sign is positive in 1 and sign is positive in 2 because it clearly says that everybody is positive in region 1. So if sign is positive in these two regions, then sign has to be negative in 3 and 4. So we're using this formula and this formula. So it could be 180 plus how much? The 18.97 and then 360 minus 18.97. Right? Like you just insert an alpha here and alpha here. The formulas in region 3 and 4. So my first answer using this is 180 plus 18.97. Again, 198.97. And to get my second answer, theta 2, use 360 minus alpha. 360 minus 18.97. 341.03. How much people got those two answers without my help, like before me? Right? Raise your hands. You can just raise your hands, right? Feel real good about yourself if you're getting this out now, huh? Because I'll be honest with you, this is one topic I hate to explain. It's like it is be stressful on me to explain. All right, take this down, take it down. I'm gonna guide you through it. I'm gonna guide you through it. Do not start the question, just take it down. Right. So this question, you can't make the call as yet. You can't determine whether this is a positive tan question or a negative tan question as yet. Right. Think of it like this. I know this tan theta, it does make things look complicated. But if it was like this, minus 3x, like if I throw away the tan theta and replace it with x. And if you wanted to solve for x, and you would throw across the positive 1.2 first to get negative 1.2, and you would minus this. And who would you throw across after? And the minus 3, who is a secret multiply to get a divide? It's the same concept here, right? We're trying to get theta on one side and everyone else on the other side. So the first person you have to throw across is the positive 1.2, just like a normal, regular, boring algebra equation. So when you throw across positive 1.2, you're going to get minus 1.2. Everyone take down that first line, right? And if you can minus the 0.85 and the minus 1.2 one time, that would be nice. Remember, it's too early to determine whether it's a positive or a negative question. 0.85 minus 1.2. I get in, I hope I do it correct, minus 0.35. I hope you all have that. Who is next to throw across? This minus 3. Between here and here is a secret multiply, right? The minus 3 is a secret multiply. Throw it across, you get what? A divide. But remember, when you throw across a multiply, the sign does not change on the other side. So now we have tan theta. When you divide two negatives, you see what's happening now? You're going to get a positive. 0.35 minus 0.35 divided by minus 3. I get in this 0.12. Because again, 0.116666666666. Everybody with me so far? They can just raise your hands. You with me so far? We're just trying to solve for theta like a regular boring equation. Now it's time to throw across who? Tan. Now it's time to determine what type of question. When we throw in across tan, what kind of value is waiting on this side? A positive. So this is a tan positive question. You think you want to take the question from there now? Finish it off. And I like positive questions. Those are the easy questions. With a positive type of question, so when you throw across the tan, you're going to get tan inverse 0.12. Right? You gain 6.84. Now, how it's a positive question, this is actually one of the answers, the alpha here. So where is tan positive? Well, tan is positive in this region, region 1, and clearly region 3. Right? We already have the first answer, alpha, right? And the formula in region 3 is 180 plus the alpha. So theta 2, our second answer is 180 plus 6.84, 186.84 degrees. Right? Right. Now, you'll get slightly different answers if you round off differently, right? Remember, when I divided these two things, I got 0.116666 on my calculator, right? Now, I decided to round it off to 0.12. If you use 0.11 or 0.117, obviously your answer will be slightly different to me. I always try to go to 2 decimal places, but at least in class, right? Right. So if you get something slightly different, don't take it on. Once you have the general procedure down, I'm happy. Right. Later on, we could fine tune on how much decimal places to go to properly. All right, let's get ready to go. All right. Just making sure that, right, for those who made mistakes, right? Make sure you see your errors, right? Let's go. Let's take some stress off. So let's see the scenario here. You gotta choose one, right? And let's hope you're part of the more popular choice. Keep track of your point. You get lost one night. Which encounter do you prefer? Okay. Do you prefer option 1, to come in contact with that werewolf? Or do you prefer the spirit? Both are horrible choices, but you want to choose the better of 2 terrible choices. Think on it and let's go. Which scenario do you prefer? It seems that option 2 won. I personally would have choose option 1. But apparently option 2 won. So for the people who genuinely voted on option 2, like you are part of that, 10 points. We we're Wolferians, 0 points. Keep track of how much points you have, keep track. Let's go. All right. This is where it's going to start to become hard. Okay? Everyone take down the question. I'm going to explain a few things about trigonometry, a little bit of the rules of trigonometry. All right. Now, trigonometry doesn't always follow the same rules as algebra. Like, for example, if you have, let me see, if you have x in here and you have 4 plus theta in brackets, in normal maths, you can multiply out the brackets, right? You could say that everyone in the brackets gets multiplied by x, right? So x by 4 is what? 4x. And x by theta is just x theta. Remember in maths, normal maths, algebra, you can multiply out brackets. Trigonometry, it's a little bit funny. Let me explain what I mean. If I have sine theta plus 10, let me just see. And common sense would say, well, based on your previous knowledge, that you can multiply everyone inside here by sine. So you say sine by theta is sine theta, and sine by 10 is sine 10. And not common sense, and that will be your first instinct, right? You can't do that in trigonometry. Whenever you have sine something or cosine something or tan something, and you have brackets after it, you cannot, just take my word for it, it's just not allowed in maths. You cannot expand the brackets. You cannot. Okay? So let me show you how to go about this question. You notice they give you this pi on 4. I think the examiner trying to tell you he's working in radians now. I want you to go back to your table. Pi on 4 is how much degrees? Because nobody, I'm telling you, nobody, no regular person like radians. Me and you, we like degrees, right? So do me a favor now. Go to your table. Pi on 4 is how much degrees? Let's convert that radians to degrees. Nobody likes radians. Nobody. How much is it? Isn't it 45 degrees? Look at it. So I'm going to assume that everybody take down the question already, right? I'm hoping you take down the question. To make life easier for you, why leave it as pi on 4? Just rewrite the question, and instead of putting radians, put the degrees. Won't that make life a little bit easier for you? I mean, just visually easier, right? Because you're accustomed with degrees. Who do we throw across first in this question? It's too early to determine whether it's a positive cosine question or a negative. The first person to throw across, you see the brackets, you have to leave that for last. This theta and this 45, you see how it's in brackets? It's being held hostage by Mr. Cosine. The theta and that 45 belong to cosine. They can't go nowhere until cosine disappears. So we only have one person to throw across right now. We have one option. That's Mr. Minus 2. And this Mr. Minus 2 is a secret multiply. So when you throw across a multiply, what do you get? We get a divide. So everyone divided for me, it have minus 0.33 divided by minus 2. Once again, when you throw across a multiply, the sign doesn't change. We have not thrown across the cosine as yet. We still cannot determine whether this is a positive question or a negative question yet. Divide these two. Let's see what we get. When you divide two negatives, you get a positive. So that's good news. 0.33 divided by 2. I put in, do the same thing like me. I go into Let me use all three decimal places. This is a real nice number. I'm feeling bad to round off that to 2. So everyone put 0.165, right? We're using the whole three decimals. Now, who do we throw across? Well, we have no choice but to throw across the cosine now. So when you throw across the cosine, when he goes on the other side, right, you get what? Cosine, oops, the bad right there. Cosine inverse 0.165. Now, here's the thing. I know it have a theta and a 45 left on this side. The hostage taker, Mr. Cosine, he going across to the other side. So theta and 45 free. They're free of their kidnapper. So they're having a little party on that side. Here's the thing. When you cosine inverse something, tan inverse something, or sine inverse something, you just have to pause the question and get your two answers. So when you cosine inverse this positive value, and this is a cosine positive question, everyone get their two answers for me immediately. As soon as you throw across a sine, cosine, or a tan, you have to pause the question and get your two answers every single time, right? You have to get your two answers before moving on. So everyone get their two answers and send it to me, and then I'll show you how to complete the question, because we still have to deal with Mr. 45 there. So as soon as we throw across the sine, tan, or cosine, we have to pause the question and get two answers before we move on, as soon as we throw it across. So cosine is positive where? By now we should be moving faster, right? Cosine is positive in region 1 and region 4. Let's cos inverse this. The cos inverse of 0.165, I get it 80.50 degrees. So this is a positive question. So our first answer is 80.85. And our second answer, right? Right, this here is our first answer. And to get the next answer is 360 minus the 80.50, right? Remember, he is what? Alpha. 360 minus 80.50, right? Our second answer is 279.5. This is our second, not final answer. That's just our second answer. So to finish off the question now, right? Remember, the theta plus 45 is equal to these two answers at the same time. That theta plus 45 is equal to these two answers at the same time. So let's draw in a little line here so we don't get confused. So that means theta plus 45 is equal to 80.50, and at the same time, theta plus 45 is equal to 279.5 degrees. You think you all could solve for theta here and theta here? For both of them, you have to throw across the positive 45 to get minus 45. And only when you solve for theta, then you get the final answers for theta 1 and theta 2. So, once again, when you cos inverse something, pause, get your two answers. Whatever you have on the left-hand side will be equal to those two answers at the same exact time. So put theta plus 45 equal to the first answer and solve for theta. That gives you your first answer. Then reput. I know reput is not a real word, but gets the job done. Put 0 plus 45 again to the second answer and solve for theta. When you throw across positive 45, you'll get minus 45. When you throw across positive, you get minus 45. My first answer is 36.5 degrees. My next answer is 234.5 degrees. I don't know if y'all can agree with those answers. Right. The 36.5 and the 234.5 is the final answers. That's 80.5 minus 40. Oh, yeah, it's 35.5. My mistake, guys. I'm correct now? If I'm correct now, you can just raise your hands. If I'm correct now. All right. All right. Now, I just want to explain the difference between this question and this previous question. You see how this theta, it had an angle added to it, like it was theta plus 45. Sometimes it's theta plus an angle, sometimes it's theta minus an angle, right? Before I move on to our next question, right? I'm sorry, let me just, I wonder if I should have do, okay. I want to test something. All right. This question here is a little bit different. It's going to cause some headache. You see, when it's theta and you have a something being multiplied by it, like the last question was theta plus 45 degrees. This one here is 2 theta. There's a secret multiply. 2 multiplied by theta. When it's a multiply, it's a little bit headachy. Take down the question. When we do it, you might be a little confused because it's coming close to the end of class and you're low on energy, right? Don't be too bothered if you didn't catch it 100%. Next week, when I'm redoing some questions like this, at the beginning of class, when you have real energy, it should make sense 100%. But anyway, take it up. Just know when it's a multiply, it gives some problems. And take down this yellow note here. If the number touching theta is more than 1, it's clearly more than 1. 2 is more than 1, right? You will see the instructions there. Then add 360 degrees, 1 less than the number. That makes no sense right now. I have to show you it. Right. So, to do this question, the first person you have to do is draw across the cosine. You have no choice because the 2 and the theta being held hostage. They belong to the cos theta, can't go nowhere until the cos theta goes across to the other side. So when you draw across cos theta, you're left with 2 theta, and you end up with what? 1 second. You end up with cosine theta. This is clearly a cosine question, but when you're going across on the other side, and it have a negative sign, we know what to do when it have a negative sign, right? We ignore the negative sign. So everyone find cos inverse of 0.45 and get your 2 answers for me. Remember, when it's negative, the first answer you get doesn't count as an answer. It doesn't count as an answer. You just use that to get your 2 answers. Right, so get your 2 answers and wait on them. Let's hoping you get this part at least. When you cos inverse this, you're getting 63.26. Right? This is your alpha value, right? But it's really a negative question. Ask yourself, where is cosine negative? Because at the point of throwing across the cosine, a negative value was weighted. I think cosine is negative in 2 and 3 because it's positive in 1 and 4. So it will be negative in the other 2 regions. So use the formula here and use the formula here. Anybody getting this answer? 116.74. And the other answer is 180 plus 63.26. Anybody else can agree with that? Those are it. So far, right? 116. Right. Right. Open everyone got that. Right. Now let me tell you what the yellow note means. The yellow note means that each of these answers, we have to add 360 degrees. But how much times do we have to do it? We do it one less than the number touching the theta. What number is touching the theta? 2, right? How much is 1 less than 2? 1, right? That means we have to add 360 to this number once, and we have to add 360 to this number once. So take the 116.74, 116.74, and add 360. You will get what? 476.74. And do the same thing to the other value. Add 360 once. If it was 3 theta, they're saying if, like it was 3 theta, you would have added 360 once, get this answer, and then you'll add 360 again. So you end up with 3 answers on top and 3 answers underneath, making it 6 answers in all. But because the number touching theta is 2, 1 less than 2 is 1. So you add 360 once to your first answer and 360 once to your second answer. Well, we're not finished yet. And we end up with 4 answers. All of these 4 answers are equal to 2 theta at the same time. Remember, we had 2 theta on that side. You can't forget the 2 theta. So that means 2 theta is equal to this answer. 2 theta is equal to this answer. 2 theta is equal to this answer. And at the same time, 2 theta is equal to that answer. We have to solve for theta now. Theta 1, theta 2, theta 3, theta 4. It's going to be real easy. This 2 is a multiply, throw it across, you get a divide. In other words, you're going to divide all the answers by 2 to solve for theta 1, theta 2, theta 3, and theta 4. And when you divide all of them by 2, you're finished. That's the end of the question. And so if you want to thinking about contemplating your life choices, like why did you choose maths? One. Right. Get your 4 answers, and that's the end of the question. Double checking. Divide all of them by 2, 476.74 divided by. All right. All right. This one here needs a lot of practice. This particular one where you have to add the 360, like when the number touching theta is a multiply, like 2 multiplied by theta, 2 theta. This one takes a lot of practice. Right? And of course, we'll be practicing this next week a lot.